You're watching Cetome TV. Knowledge is power.
So this is from Anthony. Anthony, will there ever be a cure for cancer? Why or why not?
That is an excellent question. I had that discussion just recently with an oncologist. And so the areas of genetic control, which are involved in cancer, are first off, genetic mutations. And these create altered proteins that cause cancer cells to grow when they're not supposed to. That's a natural process. So it's important to think of cancer as a wound healing process. In other words, it's a natural process that has been turned off, that was only supposed to be turned on temporarily to fix something, but now it's stuck on. It's like a gas pedal. You press the gas pedal on and it stays on. So I think it's really important to understand that that's what cancer is it's a natural process that, to fix the body, but it's broken. Certain control regions are broken on it.
So the cancer really, the way we think of it, really refers to once it's broken and now staying on.
Staying on, yes.
Right.
Yes, it's called proliferation.
Okay.
And now there's other factors, but that's the main general rule for cancers. It's constant proliferation.
All right.
So that's often controlled by genetics. Now we have another area that is quite interesting called epigenetics. And epigenetics is what I studied. That's the regulation of the genes. So epigenetics is involved in a process where, so all of our cells have the same DNA. I mean, this is a generalized rule. And of course, our different cells have different DNA by the time we're 70 or 80 because of mutations and alterations based on environmental interactions.
But all other things being equal.
All things equal, we're born with the same DNA in every cell. So the way our bodies actually produce different tissues out of that same DNA is they turn certain genes on and certain genes off. So you have the same set of genes, and certain genes will be turned on in your hair that are not turned off in your skin. And then other genes will be turned on in your skin that are not turned on in your hair. So we, once again, we have the genetic code to literally do anything with our bodies. We could, as I mentioned before, we could grow butterfly wings if we wanted, if we turned the right sequences on. The genes across all species are fairly similar to a certain degree. So that is the epigenetic programming, and it basically refers to the turning on and off of genes. Okay. We're just getting started in understanding how to regulate that, and we have a couple of different genes that target that called methyl inhibitors and acetyl inhibitors. Now the third, and this is hopefully the final frontier of cancer treatment.
So there was genes and then epigenetics.
And then epigenetics, and now there's a microbiome.
Okay.
So the microbiome is basically all of the pathogens, and I say pathogens loosely because a lot of these bacteria and viruses that live within us are important, and they're synergistic. They're symbiotic. So this network of different bacterial and viral and fungal and amoebas and all these different species in our body regulate cancer genes. They control cancers. They produce proteins that cause cancers. They inhibit cancers. There's so many different things that they do, and it's going to take us a long time to really figure out how to control all of those.
So there's 3 different places or spaces where cancer occurs.
Exactly. Well, 3 different mechanisms.
3 different mechanisms by which cancer will occur. Yeah. Thank you.
So we're doing really well with genetics. We've got a lot of that done. We're creating
new targeted differences to how long people are living.
Exactly. We're coming up with new targeted therapies daily, literally, and new targets. That doesn't. We're pretty well close to mastering that. Epigenetics, I say, will probably be another 20 years, 25 years. Microbiome, maybe another 50. So I'm giving it 100 years.
100 years.
100 years. I think we'll be able to eradicate all cancers in about 100 years. Okay. If things keep going the way they're going.
Okay. And that's factoring in for how rapidly things are evolving in science and tech?
Could be quicker. Yeah, I'm saying 100 years is a safe bet.
Okay. All right.
Let's say by the end of this century.
Great question, Anthony. So yes is the question. It's just that depending on your age, I know I won't be here to see it.
If you look back at what doctors are doing 100 years ago, they were bloodletting, and trepanning, drilling holes in your head, and so on.
Yes, we've definitely evolved.
But I think it's important to understand that at least 40 to 50% of the DNA in our body we got from viruses. So, these pathogens are very important parts of how we became humans.
Somehow, right.
Definitely.
And they are just sometimes going a little sideways
right.
too.
So it's not a matter of just curing the cancer. It's a matter of understanding, how to cure the cancer without affecting evolution.
Right.
And adaptability.
Right. Or harming the human being.
Harming our species, exactly. Being able to maintain evolution.
An interesting topic. Great question, Anthony. Thank you.
Thank you for watching Ketome TV. Subscribe below and stay informed.